doing today?
Good. How are you?
Good. You got any schoolwork to go over, or you want to go do ACTs?
ACT stuff, because we had our test yesterday, or today and yesterday, and I thought I did pretty well on it.
Good. Good. Okay. Yeah, let's finish this last few pages of what I have from McGraw-Hill, and then I did find the other tests that tend to focus more on geometry, and we can go to those next. Now, remember, we're still in the section of problems that is the high degree of difficulty. Okay, how about 49? We left off on 48, which of the following was a perfect trinomial. 49. I found that a good way to start on problems like this is let's come up with a couple of integers that satisfy the first part of this sentence. What two integers would be both negative integers where p would be equal to 2 times q?
1 and 2.
Got to both be negative integers.
Yeah, -1, -2.
Okay. And which of the following must be a rational number? P plus q?
Yes.
Yeah. You don't get irrational numbers unless you're dividing. In other words, I could add up a string of integers, and I'm always going to come up with an integer. And that's all we're doing when we add p plus q. If they're both integers, that has to be an integer or 0, which is considered rational. Okay. How about p over q? It's definition of a rational number?
Isn't it just a whole number?
No, it's any number that can be written as a fraction. Now, a whole number, 5, certainly can be written as a fraction, like 5 over 1. That's rational. 4/9 or 4/7, that's rational. What's not rational? Square root of 2, pi, e, natural log of 3, numbers like that. There is no way to express those as a fraction. In other words, or if a decimal, in other words, you say, well, I can write that as 1.41 and go, how come I can't make that a fraction? Because the decimal goes on forever without repeating. So what fraction would you make it? Okay. So, getting back to this problem, p over q is one integer over another. We're writing it as a fraction. That's rational. What would present a problem making this rational? Q or 0? But it can't be 0 because they've told us that both p and q are negative integers. And 0 is neither positive nor negative. Okay? 0 is even, incidentally. It's just neither negative nor positive, but it is even. It's not an odd number, it's an even number.
Okay.
And q over p is the same thing. No matter what q is, no matter what p is, I'm going to end up with a ratio, a fraction. So 1, 2, and 3 are all true. This is actually a relatively easy one, as long as you know the definition of rational. It's not like people. You have rational people and you have irrational people, like Donald Trump. But numbers don't have any judgment. In other words, there's nothing saner about a rational number than an irrational number.
Okay.
Okay. All right. These are, well, let me read this one. Go ahead and read it silently to yourself.
Okay.
You know the answer? First I thought it was a dirt. In other words, I thought, and just generally reading this, there's the master equation you always want to remember. D equals RT. Distance equals rate times time. Okay? You're going to run into some tougher problems that require that. So make sure that's one of your master formulas that you memorize. But this problem, we don't really need to go in that depth that much. How many minutes did it take her to get to Alan's house?
Wouldn't it be cut in half?
Yes.
So G?
Yes. Not G. In other words, the total, what expression for the total number of minutes she biked? Well, she biked X minutes going. She biked half of that coming back. That's equal to 3/2 X. J.
Oh, okay.
Okay, in other words, you need both expressions. The only difficult part is coming up with that, and that's not that difficult. If she rode twice as fast, clearly she's going to get there in half the time.
I didn't read the full, the very last part of the entire trip.
Right. And that's key when taking the ACT. In 7 years of tutoring it, whenever I make a mistake, it is almost entirely because I didn't read the problem properly. So reading the question is really important. Something else. The first time you take the ACT, you want to make sure you see all 60 questions, okay? There's no way you want to run out of time on the 50th question, because you might have some easy questions that are in 51 through 60. They don't always get a lot tougher. And so the first time through, really, you're trying to isolate problems that you think you can do versus problems that maybe you don't think you can do, or that look hard enough to be put off to the second trip around. Speed is usually a factor, okay? No matter how smart you are, you're going to run out of time. You'd rather run out of that time after looking at the 50 easiest questions. If you don't look at the 10 most difficult, it's not a big loss. You know what I'm saying?
Yeah.
But if you don't look at 10 of the easiest ones and you don't get a chance to do those, that is a big loss, because you're going to get 9 out of 10 of those correct. So, my point being is that when we first look at this question, it's got 7 lines in that paragraph. Most people are going to assume that that is a really difficult question. There's going to be a lot of students that the first time they look at this, they're going to put a double check mark by it. Meaning, come back to it later. If you don't have time to get to it, guess. Well, you can see from this one that this is not a tough question. This is actually a very easy question. The fact that it has 7 lines in the paragraph is not always reason to assume it's a hard question. This was really easy. You didn't even have to use D equals RT. Could have solved it using D equal RT also, but it's more work that way. So don't make the mistake of assuming it's a hard problem just because it's got a lot of words. For what real value of R will S have its maximum value? Just look at it for a second. Try to reason it out. In other words, S is big when 5 plus R cubed is either small or what?
Negative.
Correct. And in fact, the more negative it is, the better.
So E?
Yep. Well, the question is 19 minus or plus 14 cubed, is that bigger than using the smallest value for sure, 19 minus 6 cubed? So if we're going to use a positive number, we're going to want to use the smallest one, right?
Yeah.
But if negative numbers make S a lot bigger. $52 is pretty easy. We're actually seeing 4 problems in a row here that are really quite easy, even though they're in the 40s and 50s.
Yes. So
it's one of the measures of the interior angles. And they're referring to this angle here. They're not referring to a central angle. So what's the measure of the sum of the angles? What's that formula?
Isn't the number of sides minus 2 multiplied by 180?
Now, when you're taking the test and you're looking at that and you're not sure if that's right or not, does that work for a triangle?
Yeah.
Does it work for a square?
Yeah.
It's right. If it works for those two, you got it right. So, what's the sum of the angles in this octagon?
1080.
6 times 180, right?
Oh.
In other words, n minus 2 is 6. We don't actually need to convert that because there's one more step. That's the sum of all 8 angles. So each angle is what? Got to divide that by 8.
Yeah.
Okay, and now it's better that I didn't multiply it out because I can do some things. I can simplify. 4 goes into 180 45 times. So I can do all of that in my head without a calculator pretty easily. 135 degrees. Check it. Does that look right? Yes. Had I come up with an answer of 85 degrees, I look at it, no way. That's an obtuse, that's an obtuse angle. Let's make sure our answer is obtuse. And in fact, say you were running out of time on the test and you hadn't gotten to this question yet, and you look at your answers, you can immediately throw out the first 3. and narrow it down to J and K. So if this was a question you were guessing on, because, you know, the bell was about to go off, guess between J and K. They are in a, there's a lot of the answers in the multiple choice that you can rule out immediately. Are you going to take the SAT, Mitch?
I'm not really sure.
Okay, because this is the first year they've changed it.
Oh, at school they're paying, or they have us taking the ACT.
They have what?
We're taking the ACT at Chatfield.
Right, right. No, Colorado tends to focus on ACT. But if you, like when I went to Mines, I had to take the SAT. But I went to high school in Maryland. But Mines wanted the SAT. So depending on where you go to college, you might run into a college that wants the SAT. But just to let you know, the SAT changed dramatically in 2016. No essay session. It's now maximum 1,600, not 2,400. The multiple choices only have 4 answers, not 5. There's some parts of the SAT they won't let you use your calculator or a calculator on. So your math skills are going to have to be a little bit better. So there's a few things that you should be aware of if you are going to take the SAT. Certainly let me know. I'm going to pick up a booklet on the new SAT. The most important change they've made, as far as I'm concerned, is giving a non-calculator section. Just because that means everybody has to be up on their math skills big time, whereas you don't really for the ACT. Now, I'm going to guess, just looking at this, that this is an easy question.
Okay.
Despite the fact that it's got 10 lines in the question. The hardest part about this question is the 30 seconds that it's going to take us to read it. And I haven't read it before. So let's have a look. It's a 5-year period. The beginning of 95 to the end of 99 is not a 4-year period. That's a 5-year period.
Yeah.
Okay, what's a good way to begin here?
I don't know, like,
Well,
kind of thinking of just...
Let's look at the CDs. Okay, they tell us that it increased from 5 per year to 9 per year. So in 95 it was 5, in 99 it was 9. Okay, so we know that information. And I'm assuming that it increases linearly, so that in 97 it was that, 6 there, and in 98 it was 8. So that's what's happened to CDs over that 5-year period. During the same time period, the average number of video games purchased by teenagers increased from 2 to 10. Well, they must go 2, 4, 6, 8, 10.
So that's how I was thinking of doing it. I thought there was an actual like math way to do it.
No, but like I said, this turned out to be really, really easy. They gave us, as long as you read the question and understand what they're giving you, then laying it out like this, you can't go wrong. There's no math involved at all. Basically, what you're doing is creating a table and finding the year on the table where that value is the same as that value.
Okay.
Ah, my favorite problem.
Isn't it
Go ahead.
F?
I think you know the answer right off the bat.
F?
No.
Wait, no, never mind.
G.
Yeah.
Okay.
Yeah.
In other words, here's the key. And it's amazing how often you see this problem on the ACT. If I have like that,
Yeah.
and in other words, if the transversal doesn't go all the way across, it ends up looking like an M. Rotate this 90 degrees to the left and you got a big M, right?
Yeah.
Okay. Well, the secret is the sum of the interior angle 1 and the interior angle 2 is equal to that.
Okay.
So what's X?
It would have to be 45.
Correct. Now, knowing that little secret saves you a lot of time on this problem. Here's why. If I don't know that secret, then I have to do it the hard way. I have to basically extend that all the way to there. And I know that's 40. Now I can figure out, well, that's 40 because it's alternate interior. And they're telling me that's 85. So this has to be 95 because they're a linear pair. And the sum of the triangles has to be 180, so that's got to be 45. In other words, that's the other way to do it, is to extend one of these lines so that it makes a complete transversal, and then you can use your parallel lines and transversals to figure out all these angles. But if the problem looks like an M, either pointed to the right or pointed to the left, this one's an M pointed to the right, then always know that that middle angle is equal to the sum of the two angles inside the shoulders of the M. In other words, as long as your M is like that, angle 1 plus angle 2 is equal to angle 3, as long as those two lines are parallel.
Okay.
One.
Yeah.
2.
Yeah.
3.
I don't.
No, it's the associative property. In other words, whenever we have two entities multiplied together, that's the same as y times x. Well, A is one entity, B plus C is another entity. So A times B plus C is the same as B plus C times A.
Okay.
Okay, so it's again 1, 2, and 3. All right, a good trig question. It's the first step.
Can't you just split
Which
tangent up?
Yes. In other words, which identity do you need? Which of these three terms do we want to replace with an identity?
Tangent.
Okay, replace it with what?
Sine over cosine.
Now, what is that all equal to? In other words, when we have a fraction in the numerator, and we have just a regular thing in the denominator, what's that convert to?
Wouldn't it be sine over cosine multiplied by sine times cosine? Would be sine squared?
If you have trouble figuring this out, put a 1 under there. Now we have a fraction divided by a fraction, and this is going to be sine x over cosine x times what? Times the reciprocal of that, right?
Oh, yeah.
So 1 over sine x cosine x. Now simplify that.
1 over cosine x, or cosine squared x.
Correct. The trig questions on the ACT are really very easy. That's not as hard as it's going to get, but close. In other words, in order to do this one, you had to know the identity for tangent, and by the identity, I meant it's not 1 over cotangent, the quotient identity, the identity for tangent that relates to sine and cosine. That's what we're looking for. Once we make that sine over cosine, now I can simplify the whole thing quite easily. If I were to make that 1 over cotangent, it'd be harder. And I'd have to put in the identity for cotangent, which is cosine over sine. So it would be a lot of unnecessary work.
Okay, that makes sense.
The most important identities in trig, whether it's for the ACT or anything else, are those 11 identities. The 6 reciprocals, and tell me if you don't know what I mean by these terms. You know the 6 reciprocal identities? What's the reciprocal for sine?
Isn't it 1 over...
Let's review all of them, because these are important. So sine of x equals 1 over what? And let me help out a little bit. We're going to list the 3 most important trig functions, the ones that are on your calculator, on the left. Okay?
Okay.
One of these is obvious. What's tangent?
Cotangent.
Which means is all we have to do is figure out whether the secant goes with sine or does the secant go with cosine. Goes with cosine.
Cosine, yeah.
And the way you can tell, there is exactly 1 co in each of these pairs. There's the co for the bottom one, there's the co for the middle one, and there's the co for the top one. One and only 1 co.
Okay.
So what's the cosecant x equal to?
1 over sine.
Yeah, so these 3 here, you don't have to memorize. The only ones you really have to memorize are these 3, and you've got all 6 of them memorized. Okay. The 2 quotient identities, which we just had to use. Tan is equal to, what was it again?
Tangent equals to sine over cosine.
And the other one they want you to know is cotan, but you don't have to really memorize that. If you know this one, cotan's got to be the flip of that.
Yeah.
And there's 3 Pythagorean identities, which you have to know at least 2 of them. And they're called Pythagorean identities because everyth's squared. In other words, it's a little like the Pythagorean right triangle. What's sine square plus cosine square?
Tangents. No, 1.
Okay. And then the second one looks a little different. The 1 is on the left side of the equation. What goes over here?
Isn't it? Yeah, it's secant. And then the other, then cotangent is cosecant.
Correct. So the third one you don't have to memorize. You just have to know that it is the co-functions of the second one. Now, don't be confused when I say co-function. Co-function is not the same as reciprocal, or not to be confused with reciprocal. Those reciprocal relationships, I said there was only one co in each pair, but they're not co-functions. Co-functions, cosine is the co-function of sine, cotangent is the co-function of tangent, cosecant is the co-function of secant. So the co-functions, to memorize them are really easy. And you don't really have to know what their properties are for this ACT test.
Okay.
But you do need these 3. So those key 11 identities, make sure you know those. We just covered all 11 of them. Again, let's try a number. Pick a number for x. We'll see if this is true.
1.
Is that true?
No.
Okay. So it's not true for 1. In other words, E is definitely not true. All reals? Clearly not. If it doesn't work for 1, it's not going to work for all reals. Positive numbers? Nope. We just tried a positive number. It didn't work. Negative numbers?
Yeah.
Correct. In other words, incidentally, when you're picking numbers, and I said pick a number, I would avoid 0 and 1.
Okay.
0 and 1 happen to be unusual numbers, and that 1 divided by 1 is still 1, whereas the inverse of 2 is 1/2. So there's some problems with both 0 and 1 in terms of using them to test certain things. But 2, 2 is great. Let's try 2. Now remember, we have to put that in parentheses. We're cubing it. What's that answer?
It would be 8.
And on the other side, we have minus a minus 2 cubed, which is minus a minus 8, which is positive 8. So negative numbers appear to work, and in fact, all negative numbers are going to have this same thing. Anytime you take that negative number and cube it, it stays negative. If you add that extra negative sign, it stays positive. And the left side of the equation is always positive. So I'm going with C. Clearly, we didn't need odd numbers. We satisfied this thing with an even number, a negative even number. And 1 didn't work. So it's clear C has to be the answer.
All right.
So we have a quadratic. And there's a constant there. We just don't know what it is. But we do know some rules about what kind of solutions you get from quadratics, right?
Yeah.
Remember how to tell whether there's three kinds of solutions you can get. You can get two real solutions. You can get two imaginary solutions, or you can get one real solution. Do you remember how we tell in any quadratic? In other words, let me give you this quadratic right here. Before I even attempt to factor that, I can tell whether I'm going to get two real solutions, two imaginary solutions, or one real solution. What do I have to look at to tell that? It's called the discriminant. What's the quadratic formula?
It's minus b plus or minus a square root of b squared over 2a.
Everything that's inside that radical is the discriminant.
Okay.
That part right there. So, by analyzing that, if it's positive, we're going to be able to take the square root of a positive number. That'll give us two real solutions because we've got a plus and a minus. So we're going to have two solutions. If it's negative, then we're going to be taking the square root of a negative number. We still have a plus or a minus, so we're going to have two imaginary solutions. If it's precisely 0, then the only solution you get is that, minus b over 2a. Plus or minus 0 gives you the same answer. So what we're looking for is where b squared minus 4ac is greater than 0. In other words, we're looking where the discriminant is positive.
Okay.
Well, that should be easy enough. What's b squared?
B squared is 4.
Minus 4 times a, which is 3 times c, and that has to be greater than 0.
So would it be f?
Correct.
To make it a -1?
Correct. All the other answers make that negative. In other words, they didn't really, when they said two distinct solutions, they didn't really distinguish between real and imaginary. So this is a little bit of an ambiguous question. I'm assuming they're ruling out imaginary. I don't think they have a lot of questions regarding imaginary numbers. You don't really have to know complex numbers for the ACT test. So we're going to assume that they're saying two distinct real solutions. They left out the word real, which they shouldn't have done, because some of these, all 4 of these answers make this thing negative, right? 1, 2, 3, and 4 give you a negative discriminant. So all 5 of these answers give you two distinct solutions. It's just F gives you two distinct real solutions, and G through K give you two distinct imaginary solutions. So F is it. And that's one way to figure out how to get around their ambiguity. In other words, you wouldn't want to get hung up on the fact that they don't tell you whether they're talking real or imaginary. You can basically rule it out, because if they were talking either one, all 5 answers work.
Okay.
So you have to assume they're talking real, because to produce two real solutions, the only way you can do that is if C is negative. In that problem.
Negative.
All right. Some good geometry problems here. This looks like it should be a decent one. Okay, so a lot of times when they have a figure, you don't really need to spend as much time reading the first half of the question as you normally would. Because all you have to do is look at the figure. In other words,
okay.
This entire first two sentences are reflected in what you're looking at. We can see there's a right angle there and a right angle there. They're telling us PS is 20, it's labeled. And they're telling us PR is 12, it's labeled. The only thing I might have questioned was whether 12 is the distance from P to that intersection, or is it the distance from P to R? Well, it's P to R. And they want the distance from R to S.
16. Because it's a 3, 4, 5 triangle.
Hold on a moment. In other words, you didn't look at this triangle. You looked at PRS, that triangle, where PS is the hypotenuse of that triangle. So that's the 3, that's the 4, that's the 5, only it's multiples of 4, so you're right, 16. That's pretty good. It'd be easy to get bogged down here by that diagonal. Notice that the problem actually becomes super simple if you just remove the diagonal, right? And you were able to do that in your head. But if you don't see to do that, and quite honestly, I didn't. I was starting to look at this triangle, and this side was 6. Well, I'm not even sure that side is 6. I think the diagonals bisect each other. But still, the problem becomes more difficult when you do that. Once you try to analyze this triangle over here using a side of 6, I don't quite know where to go next. But if I remove that diagonal QS, now it's really easy. You're looking at a 3, 4, 5 triangle. And their final trig question. No, it's not really a trig question. Let's look at all these answers. All right, let's see. Why is the answer not square root of s squared plus x squared? Because they want it in terms of s and t. T being the slope of that ramp. Well, what's slope equal to?
Isn't it just...
Start from the very beginning, whenever anybody asks you that question. Rise over run.
Yeah, so...
Well, what's the slope when you look at this picture? First of all, it's t.
Yeah.
What's the rise and what's the run?
S over x.
So that's the slope. and they want their answer not in form of x. So let's, just looking at that triangle, using the Pythagorean theorem, what is the hypotenuse equal to?
Isn't it just x equals...
You always want to be able, no, not x, let's not solve for x, let's solve for the hypotenuse. You always want to be able to solve for any side of a right triangle quickly. There's only two things you need to memorize. Okay, if you're solving for the hypotenuse, it's always the square root of the sum of the squares.
Okay.
Okay, if you're solving for a short side, then it's the square root of the hypotenuse squared minus the other side squared. That's it. Those are the only two you want to memorize. And I do think it pays to memorize those rather than always having to go back to this one. In other words, I know you know what the Pythagorean theorem is, so you can always start from there to solve any right triangle. But if you always go back to the Pythagorean theorem, then you got a lot of manipulation and algebra to do before you can even solve for C. So remembering it directly is worthwhile. In other words, knowing that the hypotenuse, and incidentally, any of the three sides, when you're solving for them, answer always starts square root of. The biggest mistake I see people make is they leave out the square root sign.
Okay, so it's just automatically that last answer.
No, we're not done. In other words, that last answer doesn't have an x in it. All these answers have t and s. So what do we need to do? We have that relationship where t is a function of s and x. What do we have to do? We have to get rid of the x, right?
Yeah.
So how do we get rid of the x? We can have some s's, but what's x squared?
Isn't it just
what I have circled, solve for x?
x is s times t.
S divided by t. Multiply both sides by x and then divide both sides by t. So x can be written as s over t, and I'm going to square it because that's what's called for. So that's our answer. That's what they're looking for. Do we see anything that looks like that? Okay.
Yeah.
In other words, also you might be tempted when you get to this step, well, I got an s squared and an s squared, can I simplify that at all? Don't waste time doing stuff like that, because you may not have to simplify it. You could simplify that, but you wouldn't want to, because this answer is not simplified. In other words, what you have right here is what you see on the test. So a lot of times if you take the extra step to simplify it, then you got to go and unsimplify it to find the answer.
Okay.
All right. That is the end of that test. In fact, we have done all three McGraw-Hill tests. Let's go look at some of these geometry problems. Now, what these tests are is one of my students' parents went and cut and pasted. Notice it goes 23, 53, 22, 33. She just cut and pasted a lot of geometry questions onto a single practice test And the reason she did it is because I would say most of the kids taking the ACT are going to have more problems with geometry than algebra. If for no other reason than you're 2 years removed from geometry and you're only 1 year removed from algebra.
Yeah.
So it's definitely worthwhile focusing on some geometry problems. However, some of these I've never seen on tests before. If you were taking a geometry class, you would see this question, and you would see some of these others. But for the ACT, no.
Okay.
Okay, so we're not going to do all of them. We're going to skip around on some. The ones that I don't think are applicable. If you'll remember your geometry course, when you studied circles, you studied chords and what happens when the diameter meets a chord. Well, it always bisects the chord and forms a right angle. You don't need that for the ACT test. You need that for geometry, but you don't need it for the ACT test.
Okay.
Okay, so let's look at this top left one. In a circle with radius 6, what is the measure of an arc whose length is 2 pi? Well, maybe you might need that.
Oh, God.
What is the measurement of an arc whose length is 2 pi?
I don't remember at all.
Okay, arc length, yeah, I'm not sure you have to know this either, but there's the formula. S is the arc length, R is the radius, theta is the angle measured in radians, which this is, 2 pi. Okay, so it's real simple here. The arc length is 6 times 2 pi. Hold on. What is the measure of an arc whose length is 2 pi? So S is 2 pi. In other words, starting from the general, the measurement of the arc, the length of the arc is 2 pi, so I'm going to put 2 pi over there. R is 6, and I need to come up with theta. Theta is going to be in radians. What is it in radians?
It's just pi over 3.
And what is that in degrees? Because all the answers are in degrees.
Isn't that 60?
Uh-huh. So that's a useful one to memorize. Arc length. An arc length means exactly what it looks like it means. If I have, let's draw this 60-degree angle, okay? They're talking about the distance from there to there. In other words, if this was a string, and I cut the string there and there, pulled it straight and measured it. That's what arc length is. In other words, what would the arc length be of the entire arc? The entire arc is the circumference, is it not?
Yeah.
What's the circumference of that circle?
Wouldn't it be 12?
Correct. 12 pi.
Yeah.
Circumference is 2 pi r. R is 6. So the circumference of this circle is 12 pi. So there's another way to do the problem. Let's say you didn't remember this formula. Well, you certainly remember this one. The circumference of the circle, the entire circle, would be 12 pi. Well, they're saying that there's a part of that circumference that's only 2 pi. Well, what percentage of that is that? 1/6, right?
Yeah.
So we need 1/6 of 360 degrees, which would be 60 degrees. So we can come up with that 60-degree answer without really knowing that S equals R theta, and treating the problem entirely as, well, let's figure out the circumference of the circle and compare that to the arc length of what they've given us. The key here is that arc length and circumference are similar measurements. When you measure the circumference of the circle, you'd cut that string at any point, stretch it out in a straight line, and measure it. That's what the circumference length means. Let's look at one more of these. Again, I'm beginning to think this lady really didn't know what she was doing. I'm wondering where she got these questions, because I have done a lot of tutoring on practice ACT tests, and I never see geometry questions like these. But you might remember this one, 53. What's the ratio of the measurement of ACB to AOB? If you had to guess, what would your guess be?
It would be, I would say B as 2-to-1.
Make sure you get it in the right sequence.
Oh,
is that angle twice as big as that angle?
No, other way.
Other way around, right?
Yeah.
So it's 1-to-2.
Okay.
And the basic premise on that problem is really very straightforward, and that is the following. If I have a circle, and I start from the center, and I measure an angle, and say that's 50 degrees, well, this arc is 50 degrees also. Always. Whatever the measurement of the central angle is, same as the measurement of the arc. Now, that's not arc length. That's the measurement of the arc. It's a 50-degree arc from there to there. Not the same as arc length. Length would be measured in inches or feet. This is measured in degrees. Now, if that arc is subtended from that kind of an angle, this angle 1 is always half of that arc length measurement. So this angle is 25 degrees.
Okay.
Okay, so when you start from the middle, it's the same. When you start from somewhere on the circumference, whatever is subtended, in other words, this outside angle here subtends this arc. And this angle is always half of that.
Okay.
All right. That's a good place to stop. And I'll make a note where we left off, and we can pick up from this next Wednesday if you don't have school problems.
All right.
All right. Have a good week, Mitch. Talk to you next time.
All right.
Bye-bye.